Okay, I just started the recording. So we are going to record today using Blackboard Collaborate Ultra. So the way that the video will be available in Canvas will be slightly different, but not to worry. I'll make sure that it's posted in the module so that everybody can access it easily. I just fixed the problem that we had with one of the files that I wanted you to have. So I'm going to redirect you to Canvas. And if you look in Canvas, you should have a new module called Final Exam Review. So quite explicit, right? And inside that module, you are going to be able to download a file named COP2513 Final Exam Review.java. Okay, and this is what we are going to work together with today. So please go ahead, open Canvas, download that file, and we are going to use it very soon. Okay. And I just realized that the file just disappeared, so let me make sure that it's visible. There we go. All right, so while you do that, I'm going to go over a few basic announcements, updates, and stuff like that, okay? But make sure that you open that file on your desktop because we're going to work all together. This is going to be a hands-on review session. The goal being to expose you to a fake exam during this week, at least one fake exam and maybe another supplementary exercise afterward, and separate those sessions where we work on solving those pseudo exams, separate them with Q&A sessions where you can just bring up any question that you have. And when I say any question that you have, I really mean it, okay? Meaning that even if you have a question about something dating back from the first week of the class, go ahead, all right? There's no benefit to you to just keep that question and let it bother you and let it cost you point at the final, okay? Don't be shy, ask anything that you need help with. That's the goal for this week, is to address every possible misconception or misunderstanding or that you may have, just so that it doesn't affect your final exam. All right, so let me open up just a few slides, okay, to go over the reviews, and then it's going to be all live coding. So live coding and Q&A at the end. So we're going to get ready for the final exam. Course evaluation, we are at about, I think, 10% and 14% participation in each of the section. So this is probably the last time I'm going to remind you because the deadline is Friday. Okay, so I just wanted to post the last reminder and let you know that if you want your voice to be heard about this course, then Friday the 3rd is going to be the deadline. After that, I think the survey closes automatically. Okay, so just keep that on your mind, on your calendar. Exam ground rules. So we have had the date for a little bit. Okay, so Sunday is the 5th from noon 30 to 2:30 p.m. Okay, so that's confirmed. That didn't change. What got confirmed very recently, as of yesterday, as a matter of fact, is the room in which we are going to take the final exam. So it's ISA 1051. So it's an interdisciplinary science building. I have not used that room yet for a final exam, so I'm going to discover it at the same time that you are. So my advice is, okay, bring your laptop, and I have at least 2 students that I need to discuss with that expressed earlier in the semester that they might have problem bringing their laptop. So we are going to work on that. But please don't hesitate to take the initiative and recontact me if I'm a little slow to get back to you. So bring your laptop. It's going to be taken on the laptop just like an IE. Okay, right now I have it set so that it's going to look exactly like an IE. So you guys should be knowing exactly what to expect in terms of the format of the exam. Okay, nothing new, nothing left field there at the last minute to surprise you. Make sure your battery lasts 2 hours. I said no plugs available because I don't know. And I've been in rooms where honestly, this is almost true, that meaning that there is maybe 1 or 2 plugs available in a room that is big enough for like 100 students maybe. So don't count on plugs, okay? Like I said, if you have problem with your battery, if you have problem with your laptop, contact me now. This is the right time to do so. I would say bring an extension cord just in case we have access to a few outlets, but they're kind of out of the way. that's the best that we can do without knowing exactly the layout of the room. Okay. The exam is going to be taken with Canvas. Okay, so you're going to take it on your laptop just like an IE. Honor lock is going to be used. I'm still working right now on tuning honor lock because we don't need the whole gamut of monitoring that this thing is usually doing during the IEs. So I will probably simplify this a little bit. You'll have to upload your Java file. Just in case, bring your student ID, okay? Just in case we have to check your student ID during the final exam, or just in case we enable the honor lock feature that asks you to show your student ID. I haven't decided on that yet. And very, very, very important, if you have any sort of time accommodation for exam, I know that I mentioned that already a few times, but this is our last chance, right? So all the reminders are coming out again. If you have any time accommodation, please contact your SAS liaison ASAP, okay? It's a little late probably already, but just do your best, okay? Contact them and make sure that they schedule you to take the exam probably at a different time in a separate room, that is going to be proctored. Okay, this is the protocol followed at USF because the rooms that we have for the exam, we have them for 2 hours. And there's no guarantee that there's not, like 5 over final exam queued up after us. So we cannot stay in the room. We cannot accommodate, extra time and stuff like that. Same thing if you show up late. If you show up late to the final exam, you'll have until the official end time of the exam to complete it. It's really difficult for me to give any extra time under those conditions, okay? So if you have accommodation, you have more time, definitely you need to work this out with SAS, okay? And let me know when you are scheduled so that I can modify the due date on the final exam if necessary. All right. And that's pretty much it for everything I could think of. Of course, if you have questions, feel free to jump in. Just to clarify again what is allowed, what is not allowed at the exam, and let me resize this window so that I can keep an eye on the chat window. It's all nice to tell students, to ask questions, but if you cannot see the chat window, it's kind of like not working that great. So there we go. So we have a few constraints on the final exam. They are mostly the same than IE, but I wanted to recap them on the slide so that everybody has a quick way to reference them, if you are wondering. And in case of doubt, as usual, post on Piazza, ask all of your questions. So what is allowed during the exam? Very simple. Your laptop, okay? That means no phone, no tablet, no stuff like that, okay? You have one computing device, and obviously the reason behind that is that we want to be able to monitor it, okay? Question in the chat, so the chapters that we need to know and understand are 9 to 12, correct? That's correct. This is what we covered in COP2513. The chapters before that are just about, how to make a loop in Java, etc. This is assumed also that you know that, okay? Either you knew it before you covered it in 2512, or you know it now because we covered it at the beginning of the semester. So our main goal is 9 to 12, but the stuff before that should still be known to allow you to write code actually in Java, okay? If you don't know how method works, how loops works, how if statement works, then yeah, you're in trouble. But these are the chapter that we have been focusing the most on, indeed. So going back to this, so we have a quick question. Let me address the question first because that's more important. Are we going to need to use both types of loops, or can we use for each loop? So as far as I'm concerned, this is not COP 2512, okay? So I'm not going to quiz you on loops, etc. Everything that is in the early chapter of the textbook, if you know how to do it one way, then go for it. Like if you know how to use one type of loop, just a while loop, I'm okay with that. If you know how to, well, actually, I would love for you to be able also to use a for each loop because that one we studied this semester, right? But what I mean is that for the stuff that is kind of like basic Java, do your if statement however you learn to do them, do your loop statement however you learn to do them. No problem there, okay? You are not going to be forced to do things one specific way, except if this is something that we studied together the semester. Like for example, I might ask you to use a for each loop to get full credit. If you don't, you get partial credit, most of the point, but still a few points left, a few points removed. I can ask you to do proper constructor chaining, stuff like that, okay? So I hope that addressed your question. Let me know, by the way, when I answer your question, if it's not 100% clear after I'm done answering, please say something, okay, so that I have a chance to actually correct my shot. All right, cool, awesome. Thank you. Thumbs up. All right. So yeah, no extra computing device, just that's just so that what is actually protoed by Honorlock is what you are using to take the exam, okay? Your textbook, digital or print, that's fine. PDF of the slides, we discussed that during the semester. Some students ask to be able to have those. I see no problem with that. So you can have the PDF of the slides either as files on your laptop, or you can access them through Canvas during the exam. It's up to you. The ID is up to you. I recommend JGrasp. Again, it's really like disheartening when a student, messes up an entire final because they didn't upload the right file or they did a little mistake like that. That is mostly due to the way the IDE work. Okay, so if you are just beginning with Java and stuff, JGrasp is fine. If you are used already to use another IDE that you use this semester without problem, then by all means, I'm not going to prevent you from using an IDE that you like. If you need some scratch paper, pencils, pens, whatever, as long as it's blank, it's not notes, you're okay. All right. So what is not allowed? Very simply stated, anything that is not mentioned as allowed is not allowed. In doubt, post on Piazza, do like what other students have been doing all semester long when they have question about this kind of stuff. Okay, post on Piazza, and I will clarify. But if it's not in the list in the upper side, per half of the slide here, then most likely it's not allowed. Can we print the slides from Canvas? I have no problem with that, okay, as long as the slides are not annotated, because then that would turn into notes, and then I would have to allow notes for everybody, okay? So if you just print the slides from Canvas because it's better for you to access them like that, I have no problem with that. So the big deal with those exams is communication. I mean, that makes sense, right? The exam is supposed to measure your performance, your understanding of the course material. So any form of communication whatsoever, whether it's like Googling, it's a form of communication, right? You look at messages or things that people posted, a few years back or whatever, it's still a way to get information from a third party. So Googling, forum search, emails, text, anything you can imagine, okay? All of that, not good, okay? You are alone for this final exam. It's just you and the final exam, and pretty much we need to measure, how much you understood from this course, so it's your personal work only. No notes and no Java programs, like files that you have, even yours, okay, even the exercise that we did during the semester. And I have explained to a few students that ask, why this constraint. It's simply because I don't want students to accumulate, a gigabyte of Java sample code and then try during the final desperately, to match that, to match any of the previous example they have to what is at the final this year. So that's generally not working out great for the student anyway. So I want to avoid this completely, pretty much. And anything else not explicitly allowed on this slide or by announcement is actually not allowed. So that's how we're going to work for the rules for the exam. So we have the logistic rules, we have the rules for what is allowed, what is not allowed. If you can think of anything else that I need to clarify, please let me know. Again, you can post on Piazza. You can ask right now if you can think of it right now, and I will clarify that. It's very important that everybody walks in Sunday into the final exam with a very clear idea of not only the format, I think I made sure of that, but also, the rules of engagement for the final exam. All right. So with all this being said, what are we going to do this week? So we're going to try to get everybody ready for the final exam, no matter how much we need to rework, maybe go backward, etc. This is a time, this is a place to do it. Ask any question anytime. Okay, if your question, if I realize that, for example, for me to answer your question decently, I need to make an aside. If it fits in the flow of what we're doing right now, I'll do it right away. If it doesn't quite fit in the flow, I'll tell you, hang on, okay? And I'll try to do it as soon as possible. But I'll keep you in the queue, and feel free to remind me, okay? But I'll keep you in the queue so that everybody gets their personalized, pretty much, explanation. We should have enough time to do that kind of stuff, okay? We'll see how it goes. But if anything else fails, the plan is to work on those fake exams and then address Q&As, and then work more on another fake exam, then do Q&A, okay? So I already uploaded the slides for those two sessions, session for Tuesday and session for Thursday. You can download them from Canvas the same way that you downloaded the Java file we're going to work on today. There are two fake exams in the slides. So if you look at the slide, they pretty much describe everything, okay, that you have to do. All right. I took this and I put it also in the Java file so that it's closer to the format that you're used to. But everything that you have to do in the fake exam is explained here. And as you can see, by the way, this is actually the first fake exam. This is the second one. The second one is a little shorter. So we are going to start. It's shorter and a little simpler, okay? So the second one is something that if we don't have time to do it all together in class, you should be able to work on it, you know, by yourself, and come to office hours for help and stuff like that. But the first one, I chose it so that it's a little long. It requires a little bit of abstraction, and there's a lot of stuff to do in it. Okay, and it's, without doubt, this is the most complicated of the two. And also, I would say it's a little bit more difficult than what you are going to have Sunday for final exam, and that's on purpose. Okay. The reason for that is if there is any misconception in your mind about anything in the course, I want to trigger it right now. So I want us to practice with something that is not trivial, so that any problem that you have happens this week, and we can address it, and we can make a better job at preparing you for actually Sunday's exam. Okay, that's the plan. So yes, it's going to be a little rough, but we're going to work through it together, little step by little step. Okay, I'll give you time to work on something, then I'll show you the solution live coding style. All right. What else? What does java.util.star mean? Good question. So anytime you see something here that doesn't make sense, you know, just let me know, okay? So what we have here is we have the lazy programmer, aka me, way of importing things from java.util package and java.io. For example, instead of to say java.util array list, okay, and then importing another java.util, I don't know what class that I might need. When you put a star like this, it's called a wild character, a joker. This means pretty much anything inside that package. Okay. So here, instead of having multiple import statements for multiple class names from java.util, I'm saying import everything from java.util package. That's it. Okay, so it's a convenient notation. Some instructors do not like it. Some programmers do not like it. So you can access scanners, yes, definitely. Okay, you can access everything that is in that package. So I imported here everything that is in util, because this is where we got most of our stuff at the beginning of the semester. And then I imported everything that's from IO, because this is where we got the stuff for files and some of the exceptions. Okay. So when I do those two import statements, I wouldn't say I'm covered for every single little class that we use this semester. There's probably one that I'm forgetting about right now, but that covers me for 90% of the class that I'm going to need, that I studied with you guys this semester. Okay, so it's not a bad idea to write this down, to memorize it, and use it during the exam. You know how the exams work, right? They always tell you. I forgot to put the comment here, but generally, right here, there's a comment that say, feel free to import everything that you need. Okay, so that would be how you do it. Can you import java.star? I'll be honest, I never tried. You know what? Let's experiment a little bit. Import java.star. I don't think it's going to work, but it's worth definitely giving it a shot. This is pretty horrible. Package Java doesn't exist. Okay, so no, Java is not the name of a package. Then I was not 100% sure. Java is actually the root of all package. Yeah, I know. I saw that. That's why I say it's pretty horrible. When I saw the compiler pause for 2 seconds, I was like, oh my God, what did I do? But anyway, yes. So no, it's not going to work. I was going to say unfortunately, but maybe this is a good thing. So you have to at least be at the package level. You have to say, it's going to be java.util or java.io or java. I mean, we don't import java.lang because it's imported by default, but you get the idea. Okay. All right. Anything else? So please don't hesitate to jump in. Okay. Anytime in the flow. This is not meant to be like a passive learning lecture. I'm just trying to get you to do things and get ready for the final. So ask your question anytime. Okay. All right. So let's take a look together. So first, I hope everybody, if you joined us a little late, make sure that you download this file, COP2513 final exam review.java from Canvas. Okay. It's located in a brand new module called final exam review, something like that. So it should make sense. Okay. So download this file. We're going to work on it together. So what are we going to do for this fake exam? So for this fake exam, we are going to implement something that allows us to process strings. So I know this is super vague, right? But I'm starting with a vague definition, and I'm going to make it more and more concrete, okay? So we are going to have, in terms of concrete facts, we are going to have a main class. This is a public class, okay? This is the only class that's going to be public in this file. Can be only one, there can be only one. We are going to have a main method inside that public class. We're going to do a bunch of stuff in that method. So this time we have to write the main method. Okay, that's not going to be necessarily the case as a final exam, but there were a few things here that I wanted you to get practice with. So I put them in the main and we're going to write them together. So this is everything we have to write in the main method. And then we have a series of classes, and everything is going to be in the same file. Again, that doesn't mean the final exam is going to have only one file. It's possible, okay? But you should be able by now to work either on everything is in one file or to work on multiple files, okay? So we're getting practice with both alternatively. So besides the main method, what do we have in this file? What are we going to do? So we are going to implement a class named series of transforms. And that series of transform class is going to extend array list of string transformation. So it's going to be pretty much a container for a series of string transformation. What is a string transformation? Well, we're going to get there in a minute, but just to give you a heads up so that you have the big picture already, a string transformation is a class that represents any sort of modification that we can apply to a string. For example, you want to take a string and reverse it, we're going to call that a string transformation. You want to take a string and you want to replace every lowercase letter by an uppercase letter, so there is a corresponding uppercase letter, we are going to call that a string transformation, right? So an object of class string transformation, the idea is that I'm going to be able to load it with a string and call a method, I don't know, called apply maybe, and it's going to apply the transformation to the string, and eventually I'll be able to get the result of that transformation out of the object. Okay, so kind of a fancy way to encapsulate inside an object the kind of operations that we like to do on strings. And in that context, a series of transform is going to be just an array list that says, well, first I'm going to replace all the lowercase into uppercase letter. Then I'm going to reverse the string. Then I'm going to do whatever transform I can think of again on the string, and so on and so forth. So we are going to record in a series of transform a series of object of class string transformation that are each going to correspond to one way we want to modify possibly one string. And then when we have this chain of operation, we can take a regular string, send it somehow by calling a method to our object of class series of transformation, and that object is going to apply all the transformation one after the other. So the outcome of the first transformation is going to be the input of the next one. The outcome of that one is going to be the input of the next one. It forms a chain, and at the end I have an end result that is pretty much a result of applying all those transformations on a given string. Okay? So we have a few methods, like I'm going to go into the details as we work on those. Okay, I just want to give you the big picture, but you can see that we have a method apply. So when we have a series of transformations and we say apply it to this string, It's going to do whatever it has to do, apply all the transformation of the string, and then return to me the result as a string. Okay, so that's going to be the key that we, API that we use. And if I wanted to undo applying all those transformation, then I will give you a string that has been the result of applying all the transformation, and I would say, okay, this is my end result. Undo the whole series of transformation and give me back the original string. Okay, so in a nutshell, this is how it's going to work. So let's talk a little bit about string transformation. So string transformation is going to model one string transformation, one way of modifying a string. So more specifically, the class string transformation is going to be a superclass, and it's going to have two subclasses. So let's clarify that first. So string transformation is going to have two subclasses. I'm scrolling down, 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 down. There we go. A class reverse transform. So I'm going to go ahead and put it right now. Reverse transform is going to extend string transformation. Okay. So that means that the string transformation is going to be very general. It's actually a transformation that doesn't do anything on the string. It's kind of your identity if you were talking math, right? So it's your transformation that takes an input and produces the same input as output, okay? So no modification to the string. And then we are going to subclass string transformation, and we are going to say, for example, well, one specific type of string transformation that I would like to implement is the string transformation that reverses a string. So reverses the order of the character in a string. So we are going to say class reverse transform. So here's a new kind of transformation, extend string transformation, and then we are going to override some method, do whatever it takes. Again, we're going to get into the details very fast, okay? But you can see that this is going to be a lot shorter than the previous class. The previous class, the superclass, is going to be our pretty much like 80–70% of our time is going to spend in there. And then when we want to create a specific transform, we just have to override the apply and undo method. How do I apply this new transform of yours? How do I undo applying this new transform of yours? So in the case of reversing the string, we are going to just reverse the string, right? And then we have a last class called letter transform. I could not come up with a better name. So it extends also string transformation, okay? And the way this one works is you give me a parameter, which is called the shift value. So for example, a small integer like 1, 2, 3, etc. And what I'm going to do is I'm going to take every single character in your string, and I'm going to shift it by that number. So if you give me a lowercase a, and you give me a shift value of 1, then the lowercase a becomes a lowercase b. The uppercase z, the lowercase z becomes, well, something out of the alphabet, but we're not going to handle that, okay? But if you give me an x, y, z, so it's going to become a y, and so on and so forth. Yes, I can definitely go back to reverse transform. If I can find my mouse, that is. Completely lost my mouse. There we go. So I think I just added that real quick. So if you downloaded the file, you're going to have to add that as well, okay? Question, when you ask us to provide a no-arg and a to-arg constructor, is it implicit that we need a one-arg constructor, or is it not required? So it really depends of the situation. That's a general answer. But in the exams, I really try my best to not let you assume too many things, okay? So if I ask you for a no-arg and a to-arg, and I don't ask you for a one-arg, in an exam, I would say 90% of the time, that means that you don't need a one-arg constructor. If you do need a one-arg constructor, then I would either make it explicit or make it so that you cannot get things to work without having to do that constructor. So that, you know, I kind of push you against, you know, a corner and make you put you in a situation where you are going to realize that you have absolutely to have that one-arg constructor. Does that make sense? So, but 90% of the time, I'm really not trying to trick you with this kind of stuff, okay? So I will ask you exactly what I need you to write. All right. So that's pretty much the overview of this whole thing, okay? And it's, again, even the theme of the exam is a little bit more abstract than what the final exam will be. So if you are if you caught yourself thinking right now, this is kind of weird, this is abstract, yes, it's a little bit more abstract. So you'll have something very concrete for the final exam, but this is going to allow us to explore pretty much like, I don't know, a huge percentage number of what we covered the semester together. It's a problem that is complex enough that I can work in all sort of stuff inside of it, and that's why I've chosen it for this fake exam. Okay, but don't worry. If you had to solve this exam, you would pretty much piece all of this together by reading the comments. Okay, so that brings me to my first advice for the final exam. When you download the final exam, take 5 minutes to read through the comments and do like I did, okay? Skip over the detail, but things like how many classes do I have? What is the relation between the class? Do we have a super class and a few subclasses? Which one is which? What is the purpose of this whole thing? This kind of stuff can help you considerably actually organize your time efficiently during the final exam, okay? So it's definitely worth taking 5 minutes at the beginning just to read the comment, only the comment, take a sort of general idea of what's required. But don't worry, this is going to be a lot of details. You saw what I did on my first reading. I skipped those details, okay? Because I know that later I'm going to have to implement a bunch of method. Right now, I just wanted to have a general idea of what's going on. So now that we have this general idea, guess what? We are going to jump in. And in an exam, you would have task 1, task 2, task 3. I didn't do this for the practice exam here. But we're going to start with this. So this is just a description of what the main class is going to do. It's going to hold the main. We give you the minimal amount of testing. Make sure that you add yours. So in this case, we give you the minimum amount of testing, and you even have to write it yourself. So we're going to start working with that, okay? So I should be able to write the main, even though nothing else is actually pretty much implemented yet. I should be able to write the main and get an idea of exactly what this program is going to do without the details. So that's what I'm going to start with, okay? So let's take a look at the first task. 1 point, declare and initialize a string constant reference variable named log. Okay, not too bad. Referring to the string literal log default.txt. Okay, so that's by itself, this is not too bad, okay? Now there is an extra explanation here that says this is going to be the same name. This is going to be, sorry, the name of the log file that our application will use by default. So there's going to be files involved, okay? That's what I'm getting from this. So if there are files, there's going to be at least a minimum of exception handling. We will pass the string as parameter to many methods, thus the idea of declaring it once here. Okay, I get it. So we are going to have pretty much a constant there, okay? And it's going to be the name of the file where we're going to write some data at some point. And everywhere in my code, I'm going to pass this constant log, all uppercase, okay? Instead of having to repeat again the name of the file again and again. And the idea when we do stuff like that is that if I want to change the name of the file, no worries. I just come here, change that constant, and throughout the code, all of my code is guaranteed to use the new name. Whereas if I was repeating the constant, how that goes, redundancy is evil, that would not work out. So let's do this one real quick together. Sometime I'm going to give you some time on the clock to work something out first, try to work it out, and then we'll correct. When it's easy like this or like short, we're going to just do it together in one shot. So we need to declare a final string. So final is a keyword, just as a reminder, that allows you to make a variable a constant in Java. So final string, the name is given to me by the instruction log, and they want the default name to be log default.txt. All right. So again, second advice for the exam: compile all the time, all the freaking time. Okay. Make sure that every time you type, even a line, I would say, every time you finish a statement, try to compile it. Okay. As a final exam, if your exam doesn't compile, that's no points at all. Okay. You need to have at least your file compiled correctly. and then we are trying to maximize your partial credit. But if you cannot even like write one line of code like that and get it to compile, and then you add more code to it and it still doesn't compile, this is not programming, right? So for the final exam, the rules are going to be a lot stricter than for the IEs. So you need to be very, very careful. Compile all the time. Make sure that you write good Java syntax. All right. So here I have my first task pretty much taken care of. Okay, I'm going to double check, but I think that's it. Yeah, that's it. Nothing else. Second task. So generally, you have always, first task in a class that are like write attributes and stuff like that. It's pretty easy. And then it gets more complicated, of course. For another point, create an object of class series of transforms. So I saw that there is a class series of transforms like down there, okay? But I don't know exactly what it's doing, all the details. That's okay. I can still create an object of that class. Yeah, go ahead. If you have a question, just type it, jump in, okay? Or even grab the mic. Are we using final because it said f equal default? No, we are using final because it said a string constant. Okay, uh, by uh, by default, I could have like a string log like this, right? And that would be okay. The reason for which I want to make it final is because I want to reuse it several times in my main, and I want to make sure it cannot be modified. Okay, and to be entirely honest with you, the reason we use final here is because I saw an opportunity to kind of remind everybody of the syntax, because that's the syntax that we covered during the semester, but it's kind of one of those, side remark pretty much. It's not a essential, so it's very easy for people to forget this. Okay, so I wanted to make sure we had an opportunity during the final exam review week, to kind of refresh everybody's memory on that syntax. So we are going to use it here pretty much. All right, that's okay. All right, so create an object of class series of transforms. That class is going to be the one that models a series of successive string transformation operations. So I covered that, okay, that we will be able to apply to a given string or even undo. Details below. All right, cool. So what I'm left with is a little bit of, flavor text here. Flavor text is trying to get me to progressively understand what the heck is going on in this final exam, right? But most importantly, what I have to do is create an object of class series of transform. So for 1 point, I'll take that. Okay, it's not bad at all. So series of transforms. I'm going to call my variable SOT, series of transforms, not trying to be original here. New series of. So they didn't tell me anything about uh, the, the constructors. Okay, so I'm going to assume a no-arg constructor. Um, I'm kind of like guessing at this point because, like I said, I haven't read yet the task to perform in the class series of transform. So I am going to just assume, and if I need to come back and fix that later, that's okay. I'll do it. You have to do that sometime, like in your final exam, like you had to do in the IEs. Okay, you're going to work out a very simple version of the code, and then you come back and you complexify a little bit as needed. Okay, but right now that's already 2 points, doing stuff, pretty much basic stuff. So series of transform SOT equal. Let's try to compile that. I don't think the computer is fully awake yet. It's taking a long time to compile, but it's still compiling, so we're good. All right, a little bit more work to do now. It's going to be worth 3 points total. It's in the morning, yes. The computer is still struggling with that, I think. Anyway, so now it's telling me what I need to do in the main, right? So you know how our main method usually work in those IEs, and it's going to be the same way in the final exam. You are going to keep coding, a bunch of methods from the class, from the classes that we have. So I see that one of you is getting like a unknown symbol. Double check the spelling. Most of the time, it's something to do with a series of transforms, being plural or something like that. Double plural. The of being uppercase O, sometimes it's not natural. We just type lowercase o out of habit, stuff like that. yeah, like you say, like your classmate says there, make sure that you have the S at the end. That catches me all the time as well. Okay, so yeah, me too. So make sure that that it's the spelling. If you have the same file and the spelling is correct, uh, then I'm not sure what's going on there. And they're trying to decide whether we need to make a quick break, and take a look at your file, or if we need to roll with it. Um, I would love to fix that for you without having to kind of like make a complete side, like that. Um, if you remove this line, everything else compiled, right? And so first question. And second question, you do have series of transform class, series of transform here defined. I'm assuming yes, but I just need to double check. Yes, okay. All right, so you know what? This is a review session. This is not meant to be a lecture. So we are going to get interactive here. And we are going to take a look at your codes, guys, because two of you are having like already problem with this. I want you guys to get started in good condition. So I'm going to stop the sharing on my side. So Jake and Eric, I'm going to make you presenters. We're going to do it in order, okay? So Jake first, Eric second. Let me make you presenter here, Jake. All right, so Jake, whenever you're ready, share your screen. Let's take a look together and let's get rid of that nasty little bug so that it doesn't cripple you for the rest of the session. And we'll do the same with Eric. Okay. This one time, I'm pretty sure the file that you have is in line with the one that I have, just because I uploaded it literally 5 minutes before the start.
Give me 1 second.
Yeah, I'm still sharing my screen, but it should go away as soon as somebody else tries to share their screen. If that doesn't work, then I'll fix it if it doesn't work, no problem.
I have it on my laptop, so I'm putting it on my desktop right now.
Okay.
Let's see if it works on here.
All right, I can see your code.
See if it works on here.
Series of transform. Yeah, the RO is something I do all the time too. Series of transform SOT equal new series of transform.
Okay, it compiles on here, but it doesn't compile on my laptop.
So it's that's annoying, okay, and it's even more annoying when it happens during a final and you're stressed, right? This is a Where's Waldo competition. So one silly trick that I can give you is when I type something and the compiler seems to imply that there is a typo in there, and I keep looking at it and I don't see it, okay? What I end up doing is things like, for example, I would scroll down to the definition of the class series of transform. I would select the word series of transform, copy it, and then paste it. And I know it sounds silly, but sometimes it's easier and faster and less frustrating than trying to play, Where's Waldo for 5 minutes against the computer. Okay. Sometimes they are just typos that we overlook repetitively, so that's okay.
I deleted it and retyped it, and now it compiles.
All right, cool. There we go. That's another way to do it. Okay. So let me make sure now Eric is also 100% okay, in good starting condition. So go for it whenever you're ready. You got it too? Weird that it refers to non-static context. So non-static context, this is actually good, okay? Because if anyone else bumps into those problems, at least you guys will know how to work around them, okay? If you bump into things like non-static context, generally well, there's a lot of possibilities, but I've seen the most often students put a class inside of another class, okay? If you try to put a class inside of another class, this is something that's feasible in Java, but that we haven't studied. So it opens up all sorts of little possibilities for shenanigans, okay? So double check that kind of stuff. Double check that you're not trying to use something that is non-static. like for example, an attribute, an object, etc., from a purely static context, and the main is a static context. So if you try to use anything here that has been not created as an object, it's going to cause you problem. I'm kind of generalizing a little too much, but I'm trying to give you like broad guidelines, okay? So that kind of stuff can help you like troubleshoot those kind of problems. So let me go back to my screen, and I'm going to share, reshare my screen real quick. There we go. It works. There we go. All right, awesome. So we're back on track. So let's do that, okay? Anytime you bump into problem, I'll try to troubleshoot it without screen sharing, just for the sake of saving time. Then do a quick screen share. If I cannot get it, then I'll ask you to send me the file and I'll work on it later. But if we can, within like a few minutes, get you back on track in the session, we'll definitely do that. All right. So scrolling back up, here we are in the main. We were about to get on our task, pretty much that should be task number 3 here. So we are going to call the add method on that object, the what object, this object, the one that we just created, to add several objects of class string transform. So here we go. We're going to create objects of class string transforms, and we're going to add them one after the other into this SOT series of transforms object. Okay. Each time you will also pass the log variable. So, okay, each constructor is going to take at least one parameter. That's good to know. We are going to pass the log variable to the constructor. This object are what will model a transform. So this is a flavor text explaining, again, what I explained at the beginning, okay? You will create and add the following objects. So there we go. Now, more details. So I'm going to use my class reverse transform and my class letter transform. And I'm not going to use the superclass. I don't know if you guys noticed, but the superclass string transform is very generic, right? And it doesn't do anything. It just takes the input and produces it as output. So what I'm going to be interested in putting in a series of transforms are transforms that actually modify the string. And the instruction tell me exactly what I need to do. So let's get started. So I need to call the add method on the SOT object that I just created. So it's going to look something like that, right? SOT.add, and then I want to create a new object. I want to create a new object of class. So the first one is supposed to be of class reverse transform. And there you go. I'm going to save myself like some typing and probably a few typo by cut and pasting like this. And every time you pass the log variable as parameter. So this is how the first one is going to look like, okay? SOT.add new reverse transform of log. And I could have written that differently, okay? I could have written that in 2 steps. Say, for example, there we go. For example, I could say, so reverse transform, the second one is a letter transform, I'm going to do the second one differently, okay? LT1 equals new letter transform log, okay? And then after I create the object, SOT.add letter transform one object, okay? So whether you do it all in one line or you do it in 2 lines like that, it's up to you. Why are we using log? Because the easy answer is because they told me to, okay? So I'm following orders quite blindly at this point, okay? The real answer to that, to understand what we are doing, is log represents the name of the file that we are going to use, the text file we're going to use to put some log information into, okay? So log information means, hey, it's, what time is it right now? It's 10:19 a.m., okay, on this date, and I've been converting this string into that string, okay? So step by step, in pretty much details of what the code has been doing. And thank you so much, Jonathan. I completely messed that up when I erased it. I was not paying attention. Yes, I should definitely close the parentheses here. Okay, the structure is SOT.add, and between parentheses, create a new object of class reverse transform and pass the log file name to it. So that means that this reverse transform class is going to keep track also of the log file so that eventually it's able to log into that file, information every time we try to reverse a string. Okay. All right. So one way, this way, or that way, I don't care. Okay. In the final exam, you are free to use whatever you would want, you know, as far as style goes. But what matters is that those objectives are met. So we have another, at this time, we have a string transform. I misspoke. We are using a string transform that does nothing just to be able to add it. So I'm going to go ahead and do SOT.add. And I'm going to say I want a new string transform. Always that typo. A new string transform, and I'm going to pass log. Okay. What's the reference for the reverse transform object now? Okay. Yeah, I get your question. So the problem is here, I created the object, and I kept the reference in the variable lt1. Okay. But then I pass the variable lt1 to the add method. And to be honest, I'm not going to ever use it again. So another way to do this is to create the object. And immediately you don't save the reference. You pass the reference to the method you're calling. So the main didn't keep the reference to the object. It just created it and passed it to the method that's being called. Okay. So some of you try to compile already, and you get constructor reverse transform class in class, blah, 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 cannot be applied to given type. Normal. We're going to talk about that in just 1 second, okay? But this is totally normal. This is a point where we are going to have to decide, you know, okay, do I keep writing this like that, or do I jump to that class and try to write the constructor so that my code compiles at every step of the way, okay? For now, I'm just going to finish this real quick because I want to accumulate like a few easy points, pretty much, okay? So a letter transform, a string transform, another reverse transform. There we go. All right, I'm going to grab this. And the last one is yet another reverse transform. Okay, so here we go. I have pretty much here, 2 or 3 points worth of stuff. And the reason I say that is because I want to get you thinking in terms of there are always easy points in an exam, okay? It's not a bad idea to get them. Okay, right out of the box, you know, you get your easy points, and then you feel less stressed. You know that you have already a few points, and you can keep working forward. Okay, so here I have created all of my object. The problem is, just like some of you pointed out, if I try to compile this, it's going to complain. And what is it telling me? It's telling me pretty much that I'm using a constructor here. So it's complaining for reverse transform, but it's going to complain also for letter transform, and it's going to complain for string transform. It's going to complain for all of them, okay? It's telling me pretty much I don't have a constructor that matches those types. So what does that mean? That means that I don't have a one-arg constructor that takes something like log as parameter. Log is actually of type string. So if I go down in those classes, okay, so let's start with the first one here, series of transform. That's not the one we want, but the first here, string transformation. If I look, yeah, no constructors, nothing at all. And if I look at the command here, the class must feature the following attributes, blah, blah, blah. The class will feature the following constructor, a one-arg constructor taking a string as parameter that represents the name of the log file. That sounds like what I'm doing here. Okay, so without knowing more about what this constructor is needing to do, okay, I'm going to just say what is my class here? String transform, right? So I'm going to say public string transform. I'm going to write a dummy constructor, public string transform, and I'm going to say it takes a parameter called log that is a file name. And I'm going to let it be for now, because I don't know much more about what I'll need to do eventually, but I know I need at least a dummy constructor like that that's going to accept, you know, that parameter. So now it says invalid method declaration return type required. So this is because I butchered my my string transform. Let me see, string transformation. Yeah, do that. Okay. So this is like second level of typo. This is a semantic typo. All right. So now I use the proper name of the class. That should work better. Try to compile it. So it should take care of one of them. Okay. So now the compiler is still going to complain, but it's not going to complain anymore about this one. It's going to complain about this one, and then complain about this one. So I'm going to fix those the same way. Okay, I'm going to go into those classes. So I'm scrolling all the way down. Actually, yeah, let's go all the way down. Let's start from the bottom of the file. And I have the class letter transform here. It needs an attribute. Sure, the attribute is already there. Probably forgot to remove it. And somewhere I need my constructor. So I'm going to go public letter transform. And this is transform, not transformation. That's what threw me off. And then string log and empty constructor. Okay, again, Control S. Let's see if that's working. Control B. So still a lot of complaints, okay? But reverse transform, yeah, I didn't do that one yet. Cannot find symbol string transformation. Okay, I'm going to get it's string transformation, not string transform. Okay, so sorry about that. There's a little bit of back and forth in my brain between the full name and the abbreviated name. So that I can fix easy. Reverse transform. Yeah, that's the one I didn't do yet. So let's go for it. Okay, I'm going to go here, and first I'm going to say, you know what, let's call them all transform instead of transformation. That would make more sense, and I will not bother you guys with those typos all the time because I'm confusing the two things in my brain. So the string transform, there we go, as a constructor named string transform somewhere. There we go. We're going for the short version. Save that, build it. All right, and now reverse transform, we need to take care of it as well. So I'm going to the end of the file, that's easier. And then scrolling back up, this is a class letter transform. This is a class reverse transform. And extends string transform. All right. And I'm going to put my constructor, actually, I'm going to put my constructor at the beginning here. There we go. Public, reverse, transform. And if I go too fast for you to follow along, let me know. Okay. You're probably not the only one that is lost, so I'm glad that you're saying something. So let's take a break and make sure that we recap, okay, what we have done, so that everybody can be on board, okay? So let me finish that constructor string log, and then we're going to recap together. So please don't hesitate to say something when I go too fast, okay? All right. So let me make sure that it's compiling, and then I will walk you through all of the steps. So incompatible type cannot be converted. What's happening here? Reverse transform of log. So I forgot to put the string because I was talking and checking the chat at the same time. I'm really bad at multitasking. String log, reverse transform, blah, 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 extend string transform. No, I don't see what's going on here. Incompatible cannot be converted to string transformation. Yes, I know what is happening in here. So, okay, we're going to talk about that in a minute. So I'm pretty much like being driven here by the compiler. The compiler tells me what I need to do next. Okay, that's like the short of the story. But before we go to the next step, okay, let's recap what we have done so far. So I'm going to scroll back up, and we're going to go like step by step. Okay, so I was working on this task. Yes, we did add a constructor in letter transform. Don't worry, we're going to go over every single thing that I modified in the last 5 minutes, okay? So that you're going to be able to catch up, you and others, no matter where you are. And let me know if you have questions, okay? So my goal was doing this. So doing this means you're going to call to create an object of class reverse transform, an object of class letter transform, string transform, another one of reverse transform, another one of class reverse transform, and you're going to add them all to the object SOT. SOT is a series of transform, right? So we create the transform one by one, we add them to that object. Okay, so here we go. New reverse transform, and it tells me every time pass the log. Okay, so new reverse transform of log. Create the object, add it. Okay, here I use the different way just to illustrate. Create the object, and then add it, and so on and so forth. Okay. So before we move any further, let me know if you have questions about this or if you're not up to speed so that I don't scroll the screen and lose you there. Okay. Line 44 and 45, yeah, is the same as line 42. Yep, they do the same work. They do it exactly in a different way. They do it in two steps. First, I create the object, okay, and I save the reference of that object. Then I pass the reference to SOT.add. Here, in this line, and all of those lines as well, what I do is I create the object, and on the fly, I don't save the reference to that object in a variable. I just pass it directly to the method SOT.add. Okay, it's like if you were saying, int result equal 2 plus 3. So you save the result of 2 plus 3 into, you save the result of the operation 2 plus 3 in a variable named result. And then you call a method and you pass result as parameter. Well, you could go ahead, call the method, and directly between the parentheses write 2 plus 3, right? So you would compute on the fly the result of adding 2 and 3 together, and then this result would be passed to the method, but it's not saved in a variable in the main. Okay, that's what we are dealing with here. Anything else? All of this good? All right, so the problem that happened is when I wrote this, the compiler told me that I was calling a constructor here, and that constructor was taking a parameter log, which is of type string, but unfortunately, there's no constructor in the class reverse transform that takes a string. There's no 1R constructor that takes a string. There's no 1R constructor in the class letter transform that takes a string. There's no 1R constructor in the class string transform that takes a string. Okay, these were all the errors that I was getting. Every single line here told me you are trying to call a constructor, but that class doesn't have yet that constructor. Okay, so what I did, I went to each of those class one by one. Let's start with string transform because this is the first one coming down there. So I'm scrolling down. And again, tell me if I go too fast, okay? Class string transform. All right. And no, I don't have any constructor. I didn't write anything yet for the class string transform. So I need to write the minimum amount of code that's going to allow me to get this stuff compiling. Here is the minimal amount of code that I need. A constructor, more specifically a 1arg constructor, and more specifically even a 1arg constructor that takes a string as parameter. All right. So let me know if you have questions about that one. If I don't see anything in the chat or hear anything, then I'm going to assume after a few seconds that we're okay. So don't hesitate to type, just even wait, something like that. And then we're going to move to the next class. So doing this allowed us to actually have the code compile when we call string transform with that log. So shouldn't it be transformation? Yes, we've been over that. What happens is that I change the name of the class to string transform. Yeah. Have to be all caps? Yes, because it's a constant. It's a convention, Stephen. It's not something the compiler is going to force you to do, but it's a convention in Java that if you have a constant name, it should be spelled all caps. So make sure that string transform is used instead of string transformation, because that confused me. I'm sure that confused you as well. Now all of our classes are named string transform, letter transform, reverse transform. There is at least some unity here. Okay. In the argument, yes, when you pass Felipe, when you pass log in the main. Okay, so let's go back up. When I call the method here in the main, it has to be uppercase because I'm talking about this variable here that I define in the main. When I write the name of a parameter, and I think this was actually your question, so I misunderstood it at the beginning. When I write the name of the parameter here, I can make up whatever name I want. So I chose log, but I could have called it param. I could have called it parameter log. I could have called it name of log file, whatever I want. Okay, does that make sense? The parameter here is just log because it's short and sweet. Okay. So if I wanted to write it all uppercase like that, I could. The compiler would not prevent me. But the convention in Java, like I said, is that we use all uppercase only for constants. Okay, this is a parameter. This is not a constant. I can say something like, you give me a value for log, so that's your constant log, right? But then I can say, you know what? Forget it. My parameter log is empty string. So the parameter can be modified, okay? When you call the method originally, you give me a constant. That constant is copied inside the parameter. So remember how method calls works in Java? We copy values. So now I can do whatever I want with log, okay, with the parameter log, right? Okay, good question, good review here on things that you need to know for the final, definitely. All right, so we did string transform. Let me keep going through the file. I'm going to go down, 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 down to the next class. So this one is kind of long, okay? The next class, reverse transform, extends string transform. So if some of you, not if, I mean, all of you, right? I'm really poorly phrasing this. All of you had string transformation written here. So please note, I changed it during the live coding to string transform, okay? Again, I wanted all the names to look the same so that I stopped going back and forth and ask myself, do I call this one transform or do I call it transformation? So the constructor is here, reverse transform, takes the parameter log, okay? Same than the other one, empty one arg constructor that takes one parameter of class string. All right? Everybody good for this one as well? All right, so I'm going to move forward. So that was the class reverse transform. We have one class left, so I'm scrolling down, 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 letter transform. So letter transform extend string transform again, okay? And then here, I already had some code, and I added, again, a one arg empty constructor that just takes a string as parameter. So I've done those empty one arg constructor in 3 classes so far, just so that the compiler would stop bothering me with these problems. Okay. All right. And I'm letting the compiler tell me what it needs at this point. Okay. So that means that when I get a compilation error, that compilation error should be specific enough that it tells me what happens. So are we going to do it like that during the final? Not exactly. Okay, this is harder than during the final. But the reason for which we are doing it hard right now is because a lot of students just ignore compiler error message. And what I want to show you here is how not only you should look at compiler error message, I'm going to help you decipher what they mean so that you get used to their weird formulation at times. And then you're going to see, what kind of error each of those compiler error correspond to, what kind of error in your code, what kind of missing things in your code the compiler error message is trying to draw your attention to. Okay. So again, this is more complicated than would be in a final exam, but this is to make sure that everybody knows at least the most common compilation error by the time you walk into that exam. Because you will make mistake in your code, and then if you don't know how to interpret the compilation error, that just makes it a catastrophe, right? So, all right, we're done with letter transform, and if I scroll down, there's nothing left. So I should be done pretty much with all of my classes. So let's compile, make sure that we don't have the same compiler errors. And if we get more compiler errors, we're going to tackle them one at a time. They're going to tell us pretty much what we need to do. So now it's compiling, it's complaining. Compiling is not synonymous of complaining. I should not have. Never mind. So it's saying when you do sot.add new reverse transform of log, it's an incompatible type. Okay, reverse transform, which is what I pass here. I pass an object of class reverse transform, cannot be converted to string transformation. So that one is easy. That means that somewhere there is still, string transformation haunting me. So I'm going to go brute force on it. I'm going to put myself at the beginning of the file, and I'm going to say, where is my string transformation? So find string transformation, and I want to change that to string transform. All right, so this way, we're not going to have anything left. And there we go. This was the last, I think this is the last spot where I use that word. So I'm going to replace it, and then I'm going to say find, and when it blinks like that, that means it has nothing else to find. So let's try to compile again. All right, on to the next one. So constructor string transform in class string transform. So okay, that's the one I added. Cannot be applied to given types. So this is one that we have been actually making a big fuss about during the lecture. Okay, because that happened to us several times during the lecture, and we did talk about it. Okay, so the idea of this one is you have a constructor like here, reverse transform string log. So let's go and find it. Okay, where is it? Reverse transform string log. So reverse transform is a subclass of string transform. Okay. My constructor here, I don't delegate with this. I didn't do something like this. Okay. I don't delegate with this. I don't delegate explicitly with super. So what happens when you don't delegate with this or super? Java does it for you. It does this call automatically. So whether I write it or whether I let Java write it for me, it doesn't matter. What's happening here is that I call a constructor from my superclass, and more specifically, I call a no-arg constructor. All right, my superclass is string transform. Let's scroll back up. What do we have in string transform? Well, what don't we have in string transform? Well, inside of string transform, I have a lot of stuff that I have not written yet. I have one arg constructor, and I don't have anything else. So I definitely do not have a zero arg, a no arg constructor. That's what's happening here. Very common problem, okay, when you write your constructor. So how do we fix it? In this case, so the fix depends on the class you are writing, okay? In this case, I'm going here, and I'm going to make it so that instead of calling a no-arg constructor here, we are calling the superclass constructor and giving it our log parameter. So the log parameter is received by the subclass constructor. It's chaining the call to the superclass constructor. It's passing along the log parameter. Again, that's the template that we have used, during our exercise and stuff like that. But this is how it can creep on you from like a left field, compilation error. So you have to be able to react to that compilation error and understand what's going on here. All right. So that's going to take care of some of my problem, but I have like two overclass. I have at least one overclass that's going to have the same problem, and I'm going to wait, no problem. So I'm not going to move the screen. I'm going to actually recenter it so that you can see, actually it moved already. Sorry about that. There we go. Reverse transform superlog. So why superlog? Because it's telling me pretty much, there we go. Let me go where the problem is, where the problem was. What it's telling me here, and yes, Robert, we have to do the same for letter transform, okay? So what it's telling me here is that if I don't write this, okay, my constructor is trying to call a constructor in the superclass without argument. Why is that? I didn't write anything. Well, it's because Java, by default, calls a superclass constructor like this, okay? So that happens, this here is inserted automatically by Java if you don't call super and if you don't call this as a first thing in your constructor, okay? So now that I know this is what's happening, I'm calling a superclass constructor that doesn't exist. I check the class. I saw that indeed I don't have a no-arg constructor. But what I have a one-arg constructor that takes the log file as parameter. So you know what? I'm going to chain with that constructor. And since it wants the log file as parameter, I'm going to give it the log file as parameter. And now we're friends. Okay? Does that make sense? Cool. All right, Jake, it is recorded. No problem. You can catch up with. That's why I wanted longer session so that we are not in a rush. I can address all questions and stuff like that. But definitely this is recorded. And let me know on Piazza, if you have any question about when you watch the recording. Okay. All right. Yep, no problem. You're most welcome. So am I caught up with the chat? Yeah, I'm caught up with the chat. Awesome. So now I fixed that problem, right? Control B, there we go. But I still have another class that's going to have the same problem. This is a class letter transform. So it's telling me indeed in the constructor for letter transform, and exactly, Jonathan will do the same. In the constructor for letter transform, you are calling a superclass constructor that doesn't exist. You are calling this. And there is no NOR constructor in the superclass. I look at the superclass. There is one R constructor that takes a string, which is supposed to be the name of the log file. So I'm just going to give it the name of the log file. Again, Control B. Here we go. Now it's finally compiling. Okay. So different dimension to what we just went through. Okay. One, to reassure you, I generally don't try to make it as hard during a final exam or even an IE. Okay. So this was harder to go through than what you are going to have to do. However, this is a great review of all sorts of compilation error message that you can get at any time in your work. Okay, so take it like that. Take it from that perspective. So the log file is coming from string transforms. So the log file is coming from, let's scroll all the way back up. The log file is coming from the main. Okay, here I have the log constant. It's a string. This is the name of my log file. Okay, every time I call, for example, new letter transform, I pass the log file. So if I go to the new letter transform constructor, right, the letter transform constructor, let's scroll down, all the way down. There we go. It receives the name of the log file. And what does it do with it? It passes it to the constructor for the superclass. My superclass is, let me put this like this. My superclass is string transform. So when I call this, I go all the way to the class string transform. It's going to be after that long piece of command. There we go, string transform. And inside string transform, I use the 1R constructor and the log file end up here. So the log file goes through the main to the constructor of letter transform, which passes it to its superclass constructor, which is string transform. And when I pass the log file to reverse transform is also a subclass. The same thing happens. Make sense? Cool. Could I have just created a NOR constructor in the parent class rather than calling? Yes, you could have done that, okay? So what I'm doing here is I'm kind of anticipating a little bit what's going to come next. If I really didn't know, if I needed to do a NOR or 1R constructor, I would check, when I have to add that constructor, for example, in a string transform, I would check what string transform wants me to do. And it tells me, hey, you can have a NOR constructor, so there you go. I could have a NOR constructor. The only difference is that the NOR constructor assumes you don't have a name for the log file, so it assumes it's going to be empty string. The 1R constructor says you give me a log file name, okay, as parameter. So pretty much what's going to happen here is that I want to pass that log file, so I'm going to use that one. If I have the information, might as well pass it now, rather than wait and have to pass it later because my program behaves a little weird. Does that make sense? All right, and I'm going to scroll back up and let me know if that doesn't make sense, okay? Yep, no problem. All right, so that was an easy point, okay? That was an easy point. That looked like it was an easy point, but it took us like for quite a spin around here throughout like most of the code, okay? And now we're going to move on to the next step. So this time we are done here. We're moving on to the next step. So for one point, you will then call the method validate. So we haven't talked about this one yet. On your object of class series of transforms. It will let us know if we have somebody Somebody was asking in the chat how you do a query replace in JGraphs, this tab here. Usually you have the browse tab, you click on find, and there you go. What you want to search for, what you want to replace. Sorry about that, but I completely forgot about that question. When I forget about the question like that, don't hesitate to ping me, okay? To retype it in the chat window or something like that. So now we're talking about a method called validate. It's a method from the class series of transforms. So we want to call it on our object SOT. And then flavor text. What does it do? Well, validate is going to check what kind of transformation we are applying. And it's going to tell us, for example, you reverse the string, but then you reverse it again. That's stupid. So we're not going to say stupid to the user. We're going to say that's weird. Okay, you sure you want to do that? Because if I reverse a string and then I reverse it again, then I'm back to the original, right? So what the method validate will do when I implement it, it will look through the series of transform, and it will pretty much count how many times I reverse the string. And if it happens to be an even number, it's going to say double check, something weird might be going on. Okay. And there are times where it will make sense to reverse, and then reverse again, depending on the transformation that's in between. But most of the time, it doesn't really serve that great of a purpose. So that's why we have a warning. So the flavor text, again, is for us to understand what's happening next down the road. But right now, SOT.validate is what I have to do to earn 1 point. Okay. So let's make sure it compiles, make sure that I don't have to write over stuff there. Nope, it's okay. So there is still a skeleton for the validate method. It does nothing, but at least there is enough of it that my code compile when I try to call it. And then last but not least, call the undo method on your original series of transform object. That's the one, SOT. And pass as parameter the following string. So that string is something else, right? So SOT.undo and pass as parameter test as a string. Right? So I get my point easily, and then I'm going to talk a little bit more, explain what happens. So what happens here is that this is, at this point, if I had to guess, I would say this is probably the output of applying my series of transformation on a message. And now what I want to do is I want to take the final output that somebody gave me. They told me how to construct the series of transformation. And now I want to reapply the series of transformation in reverse order, reverse everything that has been done to get the original version of the string. So it's kind of like encrypting, decrypting. It's a very, very trivial encryption scheme, okay? It's not a good encryption scheme or even a real one. But the bottom line is that it looks like that, right? I have a ciphertext here, a text that has been modified using a series of transform. And now I'm going to reapply the same series of transform in reverse order, and it's going to give me the clear text. So when I'm done with that, I can probably SOT.undo is going to return a string. So I can probably system.out.println and display that on the screen, okay? Just to see what was the original message. So if you decrypt everything, you get the original message. It should be something that makes sense in English. If you get some random characters, that do not mean anything, then probably that means that we didn't implement our series of transform and our transformation correctly. Okay. Yes, that's the easiest ciphertext you guys are going to ever encounter in your life. Okay, it's even an affront to call it a ciphertext at that point. Okay, all right. Okay, that's it. We went through the main. I think we are done with the main. We did everything in the main. So 1, 2, 3, 4, something like 4, 5 points there. That's again in a final exam. I would give you that. Okay, in a final exam, I generally give you the content of the main. This was just an excuse for us to kind of trigger all sort of potential problem, and make sure that everybody is okay on all list of topics that I had in mind. Okay. All right. So now what do we need to do? Well, now we have probably a more concrete idea of what the bigger picture that I first depicted was. So now we need to go and implement those classes, series of transform and whatnot. Okay. So this class will extend array list of string transform. There we go. Array list of string transform is indeed being extended. So remember, right, we have been playing with two different things. We have been playing with composition and inheritance. And we have been using, for example, container class like to-do list or invoice, okay? We have been using them as an illustration on how you can implement them by inheriting from array list, which, in the real world, it's possible one day you'll have to inherit from a release of something, but it's not common at all. And then we have been playing with the other version, which is, we create an attribute of class array list. So both of them are fair game. Both approaches are fair game for the final exam. So be prepared for both, okay? So my class series of transform extends array list of string of transforms, so we decided to go that way. And then here we go. First task in the class. Well, technically that was the first task. So second task, 3 points. This method will iterate over the array list and count as many of the object reference therein are class reverse transform. Okay, so this is the method validate. So we talked about it already. I explained the gist of it. So this is giving you the details. So you iterate over your array list and you check every object inside the array list. And if that object is of class what do they say? The reverse transform. There we go. If it's of class reverse transform, you count it. So I've met one reverse transform object. Look at the next. It's a letter transform. Skip it. Look at the next. It's a string transform. Skip it. Look at the next. Oh, it's another reverse transform. So now I've encountered 2 of them. And you keep going like that through all of your transformation objects in the series of transform. And you count as many times, how many times you encounter a reverse transform. So different class, yep, no problem, Tristan. This is recorded, and I will post the code as well. So you'll have everything to look at it. And when you look at it, post on Piazza if you have any questions. Okay? All right. And I'm going to also do this same session this afternoon. So if some of you want to come back this afternoon, yeah, feel free to do so. Okay, it's open door. All right. If that number is greater than 0, so once we have counted how many times we have those things, okay? Once I've counted how many times I have a reverse transform in my series, if that number is greater than 0 and even, that means that I did reverse, then reverse again. So back to the original, or reverse, 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 reverse. 4 times, again, back to the original. So I want to display a message on the screen that just says, using an number of reverse transform is weird. So I'm going to cut and paste that message. So I know that sometime, somewhere here, I'm going to do system.out.println, and I'm going to display that specific message. Okay, there we go. When do I display that message? So I'm going to have a int. I'm just going to call it n. Okay, this is my counter variable, and I'm going to say if. So it's going to be a double condition. So and. So if n is greater than 0, that's the first condition, and n is even, n modulo 2 equal 0. Okay, so quick reminder on the modulo here. I found a way to work that in. So yes, the syntax, we've used it a few times at the beginning of the semester, but it's easy to forget. So the remainder of the integer division of n by 2 is 0. That means n is even. Okay. All right. So now I have to do the part where I actually count how many times I have a reverse transform. Okay. So how am I going to do that? I'm going to use a for loop. The exam will probably tell you use a for each loop. Okay, just because this is a must appropriate for that kind of task. Okay, so it's going to tell you explicitly, I want you to use a for each loop. Like I said at the beginning, if you don't, you still get most of the points, but you don't get all the points because I want to make sure you know how to use a for each loop. So I'm going to show you how we do it with the for each loop. Okay, so the syntax of the for each loop again, I want to iterate over all the string transform. I'm going to call it ST. So all the string transform ST inside of my array list. Little trick here that we have been discussing many times. Where is my array list? Well, it's not an attribute. So the object itself is array list. There you go. String transform st test. Okay. And then what am I going to do in my loop? Well, I need to detect if a transform, so st, if st is actually a reverse transform. How do I do this? Well, I can do that using, instance of. So let's go. If st instance of, and I want to test for reverse transform. So is the object that represents a transformation in my series right now, the one I'm looking at right now? I'm going to look at all of them, okay, no worries. But is the one that I'm looking at right now is actually a reverse transform? What do I need to do? I need to increment my counter by 1. And there we go. So now I have a little piece of code that's going to look at every element, and I'm going to scroll so that you guys can see it and catch up if you need to. I have a little piece of code that's going to iterate through all of the elements in my array list. Okay, so all of the transformation objects, string transform objects that I've been storing in that series of transform. Okay, and for each of them, I'm going to ask myself, is that a reverse transform? Count it as 1 if it is. And then at the end, I'm double checking, well, was there an even number of reverse transform? And if so, well, better warn the user, that something might be fishy. I say might because there are legitimate reasons for which you may want to reverse a string, then do something weird on it, and then reverse it again. And you will not get the original, depending on what is it that you did, what it is that you did that's weird as far as transform goes in between. Okay, so I want to let the door open to that, but most of the time it's going to be a weird decision to reverse and then reverse again. So I'm going to just issue a warning, and that's it. Okay. All right. So what else do I have to do for validate? That's pretty much it. Okay. The whole validate has been taken care of here. I'm going to save. I'm going to build. Not too many syntax error. There we go. And we are done with validate. Next, 3 points. So this method will start by displaying the following message, blah, blah, blah. So which method are we talking about? Okay, so now we are starting to deal with, how to say, the main method of this class, okay? The class series of transform is going to have one method called apply and one method called undo. And these methods are, I say they are the most interesting, the primary method, because they are going to take a string as parameter. So both of them take a string as parameter. And they are going to, in one case, apply every transformation in order to that string, and then give me the final result. And in the other case, they are going to apply every transformation in reverse order. Actually, they are going to undo every transformation in reverse order, and then give me the end result. Okay, so this is really the method that we want to use all the time with that series of transforms. So we are going to have a little bit more work in those. So let's start with the easy stuff. Always get rid of the easy stuff first, okay? This method will start by displaying the following message. Okay, I can do that. Cut and paste. There we go. And I'm going to start by displaying system.out.println. And the message that I want to display is cut and paste of what was up there. So it's going to tell me every time it runs, right? It's going to tell me, okay, I'm applying the series of transformation on, and on what? Followed by the value of the parameter string. So this is my string parameter here, input. So I'm going to follow that by input. Okay, so I took care of up to here. It will then iterate over the array list. So again, I'm going to have a for loop and apply in turn each of the string transformation modeled by the values object stored in the array list. So iterate over the array list. So let's say for string transform st inside this. So same technique that I used before, to iterate over my array list. And for each string transformation st, I'm going to apply it to, and I'm going to call this TMP, a TMP variable, okay? And I'm going to start with, you're going to see why I use another variable, string TMP equal input, which is my parameter. So I set TMP to being my input, okay? So whatever my input is, TMP starts like that. And then I apply each transformation to TMP. Okay, and then what? The string parameter will therefore be passed to the first object of the list. Okay, so we pass it to the first object of the list. So that's how we do it. st.apply TMP. The result will then be passed as parameter when calling the apply method on the second object. So problem. Here, I call st.apply TMP. So the first transformation is used and is applied to whatever TMP was. Where's my result? My result is going to be stored somewhere inside the st object, but I haven't fetched it out of that st object. So there we go. Should we return st? So that would be one way to do it. Okay. As you read the command for this, and then later on the command for the other method in the class, you're going to realize that we do it in a way that is a little bit more complex, but that is a little bit more flexible as well. So instead of just returning here and doing TMP equal st.apply TMP, so the value of TMP becomes the result of applying this transform on the current value of TMP, what we are going to do is we are going to add one more line in our loop. Oops, I went overboard here. There we go. I'm going to add one more line to my loop, so I need to put those curly braces, okay? And that line is going to use another method that we're going to write together just in a minute, okay? And that method is going to say, I want to get the result from the current transformation. So get result. And that one is going to return the value. So it sounds a little awkward, right? You know, why don't we return the value directly? You are going to see how that works out, okay? Because the fact that we break it down into two steps is going to allow us to do the logging into the file very conveniently and all that sort of stuff, okay? But you're going to realize that at the end by the time we're done. So right now, I'm applying, so let's sum up what we're doing, okay? Displaying the message, hey, I'm going to apply the series of transform on blah, 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 then set TMP to input, go through the list of transform, apply one transform, change TMP so that it's a result of applying the first transform. And then iterate again, apply the second transform, so we apply it to TMP, so that was a result of the application of the first transform, and then get that result again, and then we're going to feed that result to the next transform. So we are chaining them, okay? The result of the first transform is the input of the second. The result of the second is the input of the third. I could probably triple check, but do we have a get result method? We do, okay? It's one of those methods that I've not talked about yet, but it is a method inside that class. We're going to write it in a few minutes, okay? So we are going to get there and write that method. For now, I'm just using it, okay? So the result will then pass blah, blah, blah. That result will then pass on to the next method, and we keep applying successfully. So to be able to do that, you have to actually look up here, you know, how undo is working and how inside of a string transform, you know, get result is working. So we are going to get there absolutely. But right now, I'm just kind of like using foreshadowing knowledge here. TMP equals st.getResult, and then feed the TMP to the next one. And at the end, I don't want to just return input because that would mean that I didn't change anything. I'm going to return the end result. Okay. One thing that I'm going to add here that's going to make it easier for us to debug. Okay. I'm going to write real quick system dot and I'm not in my window apparently. There we go. I'm going to write the system dot out dot println. And what I'm going to display here, I'm going to do a little bit of formatting, okay, like this. I'm going to put an arrow between two tabulation, and I'm going to display what I'm about to return. Again, this is not requested. It's not required. This is just convenience for me to see what's happening, as I run my code, as I'm trying to debug and figure out if it's working. So let's see. I think I have everything I need here. I'm going to save. I forgot to double quote. Yes, you're right. There we go. Thank you. Double quote here. So now it should be compiling a lot better with that double quote. Okay, it's compiling. So I have the apply method. What else do I have? I have the validate method. I have the apply method. The next one is the undo. Wouldn't you write TMP outside of the double quote? Then what did I do? Oh, yeah, okay. I'm trying to think about 2 steps ahead while I'm writing a step. That doesn't work so well. There we go. Absolutely. You're totally right, Patricia. Thank you, both of you. All right, so Control S. Now this is going to compile and is going to do something useful. Always a plus, right? So I have apply. Next one on the block, and we are going to be done with that big class. Okay, so I'll probably take a break and take questions there. We'll see, depending on if there are questions. But next step is undo, and undo is going to be very, very similar. Okay, it's going to be very, very similar, except that instead of going through the list of transformation, in the order they were given, we want to go through the list of transformation in reverse order. And instead of applying each transformation, we want to undo each transformation. That's what a global undo is, right? Undo the last step you perform, undo the one before, undo the one before, and the one before, and you get back to your original result. So we are going to follow the instruction here again. System.out.println. And I'm going to say this time the message is a little bit different. It's undoing series of transform on, and then we're going to put the input. There we go. That's input. Copy and paste, yeah, copy and paste oriented programming. Generally a bad idea, it works here, so I'm happy, but all right, so undo this. Now I'm going to do the same trick, right? I'm going to say string tmp equal input to start off with. And then after I'm done doing all of my processing, I'm going to return whatever tmp is, okay? And my processing is going to be a loop. So this time I cannot use the for each loop because I want to go in reverse order. So remember what I told you about the for each loops? They are super useful to do the trivial stuff and write it in a way that it's almost impossible to mess up. But as soon as you want to do stuff that is just even a little bit more complex, then you have to sometimes go back to the good old-fashioned, basic loops. But that's okay. For our review, that means that we review both ways. So that's good. All right. So I need a for loop, and I need a for loop that's going to allow me to go over my array list in reverse order. So I'm going to use a counter for int that int I. So I'm going to start at the end of the list. So where is the end of my list? That's the size -1. So that is the index of the last element in my list, okay, in my array list. So I still access the array list with the def keyword, no problem. And I take the size and -1, that gives me the index of the last element. I'm going to decrement by 1 my index at each iteration. So I start at the end, I go towards the beginning, and I'm going to keep going while I is greater equal to 0. That's going to be the structure of my for loop. Okay, open curly brace, close curly brace. What else do we have? So what else do we have? Now we need to apply the transformation. To apply the transformation, to undo it, actually, we need to fetch that transformation first. So string transform, and I'm going to call it st. So it's kind of like reminding you of what we did in the other loop. How do I get the element at index I in an array list? So if I'm in an exam and I don't remember that, thankfully, I bookmarked a page in the textbook that has a table with all the method from the class array list, or all the method that we use in this class. And I flip through the textbook, go find this, and I realize it's called get. and inside the parentheses, I provide the index. Okay, so I want to get the element at index I inside my array list. So st is going to be my transformation object, okay, my string transform object. What do I want to do with it? Well, I want to run it on TMP, but I don't want to apply it. I want to undo it. So st.undo, and I'm going to pass TMP. Just like the apply here, okay, the apply doesn't return anything, the undo doesn't return anything. So when we do this, it takes this as input and then stores internally that the result of undoing this transformation on that string is blah. But now I need it. I need the result. So I'm going to call the getResult method again. And I'm going to say tmp equal st.getResult of nothing needed here, just getResult. Okay. So now TMP is a result of undoing the last transform. I'm ready to pass it to the before the last transform, and I'm going to undo it again, and then so on and so forth. It's going to chain nicely, and I'm going to end up undoing all of the transforms. Okay, and that's pretty much it. Again, for the sake of debugging, I can real quick here add same print element statement that I had over there. There we go. That's going to let me see on the screen, a row TMP. st.getResult, if we didn't do st.getResult the first time, what do you mean? Yeah, I got that, but I'm not sure I understand the question. You mean like in this method compared to the previous method, or? Okay. So it's the same logic in both methods, right? The logic is you apply or you undo a transform on a given string, but it doesn't return the result to you right away. It stores internally what the result is, and then you have to ask for the result explicitly like this. So it's kind of saying process, that's my first request, process something, and then keep the result, and then later get me the result. I want to know the result now. Okay, so now we are doing it right after, but we could have 50 lines of code here that do completely different stuff while we don't need the result, and then just ask the result at the end. Does that make sense? We have apply, we have undo. Once you get one working, the other one follows the same pattern. So should we have places st in front in the apply method? Yeah, should. Because look what you do, okay? Both for the undo and apply method. Let me go back to the apply method. For the apply method, you say for each string transform st inside the array list, okay? Apply the string transform st, and then get me the result that this transformation obtained. Okay? So yeah, you apply. No, that's okay. And anything that's unclear, please ask. Okay, you apply and then you get the result. And here, instead of apply, you undo, and then you get the result. The other thing that's different also is how the loop is working, and the fact that we need to, we don't use a for each loop. We use that ugly, get index I, and we use indexes, but we don't have really a choice. So that's why we need to use that one. But it's a good review of how to iterate over array list without a for each loop. Okay. Felipe had a question too. If I process three transformation, then I call undo, it will undo all three transformation? Yes, because remember, we are in the class series of transformation. So when I say apply, I mean apply every transformation object in order. When I say undo, I mean undo every transformation object, in reverse order. So you first transformation, you turn the lowercase to uppercase. Second transformation, you reverse the string, right? If I want to undo that, I'm going to start by reversing back the string and then transforming the uppercase into lowercase. So every transformation object, every string transformation object has two methods, apply and undo, just like the series. the series as apply all and undo all, right? It's not called all, but it's called apply undo, but it goes through the entire series. And each string transformation has an apply and undo as well. So it knows how to apply itself, and it knows how to undo the changes that it made when it applied itself. Awesome, cool. Glad it makes sense. All right, what else do we have? So we are pretty much done here with, yeah, question? So I had a hand raised.
Yeah,
Go ahead
so
and grab the mic.
my question was, if I apply 3 transformations, then I only want to undo one of them. How would I accomplish that with those methods?
You can't. You can't. The
Okay,
series of transformation is kind of atomic. It's either you go through all the transformation and then you undo all the transformation, but you cannot say, for example, I want to only apply, the first transformation or the second, or up to the third, and then undo, blah blah blah. It's not that flexible. Okay, it's all or nothing. Apply all of them and then undo all of them.
got it. Thank you.
Cool. All right. So what else do we have here? We are done with the, yes, I can go back to the undo method, no problem. We are done with the hard part. No problem, Zachary. Just let me know, anybody, when you need me to scroll back up or something like that. So I want you to follow along, okay? Cut along. So that's what's pretty much I would say, the hard part, okay? There are going to be a few things that are tricky in the apply and undo in the string transform, but these are more like, because I wanted to bring back to your attention, details that are often forgotten by students. But that was actually the core of this application, being able to apply all of the transform, being able to undo all of the transform. And one thing that I want to draw your attention to is that we have been developing so far using pretty much, like, I would say, sound OOP development strategies, okay? Meaning that we wrote the main, we used classes and method because based on their documentation, based on what I was told they would do. Then I got them to be just good enough to compile. Then I wrote the class series of transform, and I did the same. I wrote series of transform based on what I was told about, the string transform and the letter transform and the reverse transform class. So for example, I knew to use undo here, that it was available. I knew to use apply. I knew to use get result because I read the whole file, when I started. But I haven't written those methods yet. So right now they are just dummy implementation of it. But that didn't prevent me from being able to write code that uses them, okay? So think of it like if you are in a team, somebody else in the team is going to write those fragment of code. You are going to just use them in your own code. That's it. You can write code like that based on a contract, based on a documentation that tells you exactly how to use another method. And progressively, we are getting now to the string transform class, which is actually another big chunk of this class. The first big chunk was series of transform, probably the hardest. This one is the second chunk, and this one is going to tell me step by step, pretty much, how to write that superclass and then the two subclass that derive from it. So we have 7 minutes left. It's too short for me to make a good dent into string transform. So what I'm going to do, I'm going to open the floor for Q&A on anything. You don't have to work on that between now and the next review session. The next review session will be Thursday, but I encourage you to maybe give it a shot, okay? Try to work through string transform, and then try to work through, letter transform and reverse transform, okay? Just to get a feel of what's expected. And then we'll go over that all together during the next session as well, okay? But for now, if you have any other question that you want to resolve, even if they're not related to that example, let's use the remaining of our time as open floor Q&A, okay? And I'm going to save that, make sure it compiles. I'm going to rename it something like COP2513 Final Exam Review AM, because we are the morning group, and upload that to Canvas so that you can download it and see where we are, okay? So it's going to be similar, yes, but it's still different questions, okay? So yeah, it's going to be similar, but you know, different problems. Sorry, it's a vague answer, I know, but can you go over chaining constructors again? Absolutely. We can even use, let's use a clean example so that it's not as complicated, okay? Let me see what I have here. Actually, I don't care what I have here. We're going to do a clean tabula rasa here, and we're going to get rid of all of this, and I'm going to show you from scratch, okay? All right. So constructor chaining. Constructor chaining, there are two types of constructor chaining, okay? You chain a constructor to another constructor in the same class, first type. You chain a constructor to a superclass constructor, second type, okay? So let's take a look at first a class public. No, not public, because I'm going to keep it in the same file. Class something, okay? Class something is just a basic class, and we're going to say that it has private int secret value here. There we go. And I want a constructor, so public something int value. And what it does is very simple, secret equal value, okay? Before we go any further, let me address Zachary's question, because I think I can address it very fast. Like you did in 2512, will you give us any of the finals from previous years to practice with? Well, this is actually a reworked final from a previous year. And if you look into the PDF of the slides, there is another exercise. There are two review exercises. This one that is long and another one that's shorter. And the other exercise is also a piece of a final from a previous year. So I didn't give you the exact final from the previous years, right? But I used two finals from the previous year to derive those practice exercise. So you pretty much have like, I would say 90% of the relevant information from both, okay? I say 90% because the stuff that was, there is stuff that I added here, obviously, to make it a little bit more complicated, to make it a little bit more meaty, you know, for the review. But there you go. Yep, no problem. Okay, so back to your question, David. So here I have a basic constructor, right? So I can go in this class here and say I want a something S1. I'm going to create an object of class something, and I'm going to pass a value of 42 because this is the answer to everything. And there we go. So I have a basic piece of code here with just one constructor. So if there is only one constructor, there's no chaining, right? No chaining needed. So now I'm going to illustrate the first type of chaining, the chaining within the same class. So what if I have a public something, no arg constructor, okay? And I want this to set the secret value to, I don't know, 23 instead, okay? All right, first way I can do the job, I can do the job like this. Second way I can do the job, I can use proprietor chaining. So that will be probably, not probably, that would be most definitively what I request for you to do in the exam, right? I will tell you, write this constructor with using proper constructor chaining, etc. So if you want to have all the points, you need to do that. What does that mean? That means that inside the no arg here, I don't want to do the assignment myself. Why? Because I have already another constructor that does the assignment. So I'm going to just delegate. I'm going to be lazy, right? I'm going to say I call something with 23. Except that in Java, you cannot write that. You cannot write I call the constructor named something with that takes one argument. Instead, the way that you refer to a constructor in the same class is with the keyword this and the parentheses. So I am constructor chaining from the no arg constructor to the one arg constructor here, okay? And I'm doing the constructor chaining using the proper method, like everything that we covered in class, okay? So that's within the same class. So that means that when I create here something, and feel free to interrupt anytime if I go over stuff you already know, okay? Let me know. If I go over stuff too fast, let me know as well, okay? If I call new something like this, it's going to call this guy, who is going to delegate to this guy, which is here, and the job is going to end up being done at the end. Okay? So that's the first type of constructor training inside the same class. So now let's talk about class something else. And we are going to say that class something else extends class something. Okay? And private int another. It's another value, another attribute that is specific to the subclass. Okay? So there are different ways we can go about this. So let's start with public something else. So I'm going to start with, you know what? Let's start with the one arg constructor int value. Right. So if I create an object of the subclass, so I'm going to say value 1 and value 2. Okay, and you're going to see why I need 2 of them. Okay, if I try to create an object of the subclass called something else, you need to give me a value for another, the attribute of the subclass, and also a value for secret, which is the attribute of the superclass. So I could try to write something like secret equal value 1, and then another equal value 2. Okay, I could try to write this, but secret is private, so the compiler is not going to be too happy about that. Okay, so I could go ahead and say, you know, instead of secret being private, I can make it protected. All of this would work, but it's actually not the preferred way of doing things. The preferred way of doing things is to say, inside the subclass, I want to delegate to my superclass constructor so that that superclass constructor takes care of initializing all of the attributes of the superclass. So I'm going to pass value 1 to the superclass, okay? And then I'm going to take care in the subclass constructor, I'm going to take care of the attribute that belong to the subclass, which is another, okay? So another is assigned a value. Value 1 is also assigned a value, but I delegate here, I chain to the superclass constructor. Okay, try to compile this. Now it's no longer complaining that secret is private because I don't use secret in the code for the subclass. So I don't go and interfere with private element of the superclass in the subclass. Okay, and then this might not be the last one, but the next one, public something else. Let's try to do another constructor, and I'm going to say that constructor takes no argument at all. So what if you try to construct an object of the subclass, but you don't give me any data for another, you don't give me any data for secret? Well, I'm going to make it up. Okay, so I'm going to make it up. And since I have already a constructor here that takes 2 values and makes sure that they are assigned properly to the attributes, I'm going to call that constructor. Since the constructor is in the same class, here and here, right? Since we are delegating inside the same class, we're chaining inside the same class, I use the des parentheses syntax. And I'm going to say, you know what, if nobody gives me a value, I'm going to assume that these are the 2 magic default values that I want to use. And I would have here an example where des constructor chains to des1, which chains to the superclass 1arg constructor. Okay? So I'm trying to come up with an example that covers all possibilities. And then the last thing that I'm going to add here is, what if you give me something else? What if you give me just one value? Well, I'm going to make up a rule. I'm going to say, you know what, if you give me only one value, that means that you want the same value for both attributes. But again, I'm not going to write des, you know, by doing the job myself. I'm just going to say I'm calling the des syntax here to allow me to call another constructor in the same class that takes 2 parameters. I just set those parameters to the same value that you gave me, and that's it. Okay, so let's use that as a starting example. Okay, did I cover everything that you wanted? Okay, perfect. Then that's okay. Otherwise, I was going to say, let me know. So maybe for anyone else, if anyone else needs a quick recap on this, let me know where you want us to go from there. Okay, what you want me to illustrate for you. All right. And if we are good on constructor training, then I would say if you have any other question, please drop it in the chat. Let me know. We'll take some time to go over like the remaining questions. If not, well, we're at the end of the 2-hour first review session. So this afternoon, I'm going to do the same thing, okay, with the other section. If you want, for whatever reason, to attend it as well, you're more than welcome to do so, or you're more than welcome to check the recording. I will record the afternoon session as well. So at the end of the day, you will have the video recording for each of the 2 review sessions that are going to take place today. You are going to have the code that we developed in the morning, the code that we developed in the afternoon. That's going to be super similar, of course, okay, because it's still the same requirements. And then tonight at 7 p.m., I'm going to have office hours. So if there is anything else that we didn't have time to address, at the end of the review session as a Q&A, please feel free to drop by. And again, the goal this week is to get you ready for Sunday. This is the last push on this course. So go ahead, put your best effort in and let me and the TA know how we can help you, okay? We're here to help you, well, during the semester, but also during this last week, okay? So it's not just the last week, hopefully, but you get the point. All right, well, thank you, everybody. I'm going to stop the recording now. If you had like a personal question or something like that you didn't want to on the recording, please hang around and we'll talk a little bit more, okay? All right, so let me find first the recording. There we go. All right, thank you, everyone.